Everything up to now has been about models that talk. This video is about a model that acts, execute code, call APIs, move money, delete files. What happens when an LLM can actually do things instead of just suggesting them? That's the agent. That's where every risk we have covered gets a real world consequence attached to it. Let's talk about the agent architecture. We see three architecture patterns everywhere. First is react, reasoning plus acting. The model alternates thought, action, observation, back to thought over and over. It is transparent. You can literally see the reasoning, but that transparency cut both ways. Because the reasoning chain can leak business logic you don't mean to expose. Planning agent. Planning agent generates the entire multi-step plan upfront, then execute it, adjusting as they go. The risk here is sequencing, manipulate the planning step, and that corruption cascades through every action that follows it. Third, multi-agent system. Multi-agent system is specialized agents collaborating, a router handing off tasks to coding agent, research agent, whatever the domain needs. Here's the risk. One agent's output become the next agent's input. That's a fresh injection vector, agent to agent. And to get worse, if the agent are running on model with genuinely different safety boundaries. So how do you actually put guardrails on something that acts? The first option is sandboxing. Any agent executing code needs to run in a container. CPU and memory limits. No outbound network unless explicitly allowed. File system scoped to a working direction only. Second, circuit breakers. Automatically halts the moment something looks wrong. Too many tool calls, weird data access patterns, anything that looks like privilege escalation. This is what stops one bad step from cascading into a full failure. Human in the loop, approval gates, but targeted ones. Irreversible actions, financial transactions, anything external facing, not every single tool call. That would make agent completely impractical. The skill is identifying which actions actually deserve the pause. And agent memory. If an agent remembers things across sessions, that memory can be poisoned. Once it poisoned, it keeps influencing decisions indefinitely until somebody catches it. Zoom out one more level, the orchestration layer wiring all of this together. Data moves between chains, tools, and external services constantly. Every single transition is a place to validate and sanitize. Treat none of them as automatically safe just because it is internal. The router. Deciding which agent handles which request is a critical trust point. Compromise the router and you can redirect sensitive queries anywhere you want, bypassing whatever security critical processing was supposed to happen. And observability. Full trace logging of reasoning steps, tool calls, every state transition is stored somewhere tempered evident. This isn't optional tooling for development. Run it in production, or you are flying blindly the moment something actually goes wrong. The and last topic, and it's hit close to home for basically everyone watching, vibe coding. Accepting AI generated code because it looks right, it compiles, test pass, ship it without actually understanding what it does. Here's the underlying problem. AI coding assistant trained on public repositories learn the good pattern and the bad ones equally. SQL and SQL injection, hard coded secrets, insecure deserialization, the model can suggest all of it just as confident as it suggested clean code. There's also the quiet failure mode. Code that compiles fine, passes every test, and still has a subtle logic bug. That's actually a security hole. And a model has zero awareness of your specific threat model. It optimizes for functionally correct, not correct for your environment. The fix isn't complicated, just consistently applied, automated SAS, DAST scanning in CI/CD, and security critical code path gets human review. Full stop. No exception for the AI wrote it. Now let's do a now let's have a quick recap what we have learned in this module. Number first, React. Planning and multi-agent architecture each carry a different failure mode. Lead reasoning, cascading plans, and agent-to-agent injection. Second, sandboxing and circuit breakers contains the blast radius. Human in the loop targets the action that actually deserve a pause. Third, orchestration security means validating at every handoff and treating the router as a real trust boundary. Fourth, observability isn't optional. Full trace logging in production, not just development. Fifth, vibe coding's core risk is underviewed. Vulnerabilities reaching production, fix it with the same security gates every time human or AI return. That closes out the technical core of this series. In next video, we bring it all together. Application security for AI products, end to end from SSRF to secure API design. If this was useful, hit the subscribe and I will see you in the next one. Thank you.